11 of Neetcode 150 to integer sum part Q. So in this problem, we're given an array of integer and a target value, and we want to render the index of the two values that can add up to the target. So for example, here in the array which contains 1, 2, 3, and 4, the index 0 and the index 1 adds up to 3. So we want to render index 0 and index 1. But the catch is that they want us to use index base of 1. So instead of starting from 0, 1, 2, 3, we're going to start from 1, 2, 3, 4. All right, so this is not super complicated. So the best technique here is the two-pointer technique. All right, so we're going to start at the first index and add the last index, and we're going to add them. If the result is smaller than the target, for example, here we have a result of 10, which is lower than 14. We're just going to increment the left pointer by 1. And also, I think I didn't mention it, but the problem is giving us an increasing array. So we don't have to care about sorting it prior to solving it. It's already going to be sorted for us. So this is something we don't have to worry about. Getting back to the two-pointer technique, we're now, our left pointer is at the index 1, so it has the value 3. And we're going to add this to the last index 9. It gives us 12. It is lower than the target. So what do? We're going to increment the left pointer by 1. We're going to have 6. So if we had 6 and 9, we have 15, which is higher than 14. So in this case, we're going to decrement the right pointer by 1 to reach 8. And now we have 6 and 8 that adds up exactly to our target. So we're basically gonna render their index plus 1 because we are using an index base of 1 rather than an index base of 0. So the first thing that we want to do is to our left and our right pointer and make sure that the left pointer equals 0 and that the right pointer is basically equal to the last index. So it's going to be the length of numbers minus 1. All right. And now, while the left pointer is smaller than the right one, we want to keep looping. And we want to see if they adds up to the target or not. So you can say addition is basically equal to the numbers at the index of the left pointer plus numbers at the index of the right pointer. And we're going to check first if addition is greater than basically the target. Well, in this case, we have to move our right pointer 1 index to the left. So we're going to do this by decrementing our by 1. If this if statement is false, we're going to go write our other elif statement. So if addition is smaller than target, in this case, you want to push our left pointer by 1 to the right. So left is going to be incremented by 1. Okay. And if both fails, if both if statement and the elif statements are false, it must mean that the addition is the same as the target. So in the else statement, we're just going to return the left pointer, that is an index, and the right pointer. But remember that we are using an index base of 1, which honestly is not an additional challenge. So if I was the person making the problem, I don't think is much pertinent to add this restriction, but still we have to take this into account. And if we loop through the array and the initial while loop breaks as the left pointer becomes equals to the right pointer and we never return a result, it must mean that there is no solution. In this case, we return an empty array. Boom, it works. So you can see that we're only looping once in the array. So this is going to give us a time complexity of O of n. And we never created an extra array. So we have space complexity of O of 1. I hope you found this video helpful, and I hope to see you in the next one.